Excellent connection. And we should be streaming something.
We are now streaming it.
Okay, so you are now live. Just wait a second for the recording to start. So, yes, welcome to this perfectly round table led by Jan on AD benchmarking.
All right, let's get started. So I have just a few slides to motivate the discussion and express what I think would be a nice thing to talk about. But then mainly this is about sort of everyone voicing their opinions. So that's why we are around this round table here. And if hopefully people have something to say. Otherwise, we can go for beer a bit quicker. All right. So the motivation. What do we currently have, and what might be nice to change? So if you've written, if you're in the business of developing AD tools or AD methods, you've probably observed that most of the time when new AD papers are written, there's some sort of scramble to come up with useful test cases to showcase in that paper. Even if you work with applications people, sometimes it's easier to get papers accepted if you have like more than one application, and then there's always, what do we do now to show the success of this AD thing that we've done? So we have certainly been, scrambling around for the enzyme papers, for example. What are we going to do? Let's just pull some DOE mini apps together and differentiate through them. But in a way, it's a bit of a waste of time to do this. And it also means that at least potentially these benchmarks could be contrived, right? People are going to be motivated to pick benchmarks that make whatever they are presenting in this paper look good. Maybe you've come up with a cool idea and you really need some benchmark to showcase that idea, but it's not clear how relevant that is in practice. So, we see contrived benchmarks. But I think some of the bigger problems are really the results are difficult to compare, right? It's hard to compare across tools, it's hard to compare across research groups, and even within one research group, right, each paper introduces something that improves performance by 10x. But if you somehow sort of cumulatively pull all those papers together, are AD tools today really, a million times better than AD tools in the 1990s? Probably not, right? We sort of pick a different baseline as it suits us. Whereas I think it would be nice if we had some sort of benchmark suite where you say, in this suite we get score X, and that's better compared to where we were 5 years ago, where we got score Y, which is hopefully less, or however the scaling is defined. So yeah, different baselines. And then also, the benchmarks that one group used are not necessarily freely available to someone else, so it just makes it very hard to compare across the field. What about AD bench, you may ask, right? There is an AD benchmark. So this thing is really tiny, but if you can just see, all the changes in AD bench 3, 5, 6 years ago. There's actually a change 2 years ago, but that's an automated policy bot that changed some README files. So really nothing has happened in the last 4 years. Also, it comes out of one group, developed at one time. It has it has 4 test cases. Hasn't changed. So on its own, I don't think it's enough, but maybe it's a start, right? Maybe we can build on this, because even today we've seen a few talks that did something with AD bench, so clearly there's a need, right? And maybe we can build on this. Other communities, right? We have machine learning people have more than one benchmark, and I think they've really driven the field forward. The optimization people have something like Qtest, there's Polybench, there's Data Race Bench, ... It seems like every community has a benchmark suite. Why don't we, right? That's sort of the question. Well, why don't we? It's very hard, right, to sort of preempt some of the things that will probably come up in this discussion. We have multiple input languages, unlike, for example, an optimization tool where maybe you can sort of canonicalize what an optimization problem looks like. Maybe for AD, it's not so easy. Every tool well, most tools are written for a specific language, so maybe there's not even a lot of overlap between, what benchmark test cases could you compare PyTorch with Tapenat, for example. Really, there's nothing, right? But then we have at least one tool, Enzyme, that can actually do multiple languages. So maybe something could be cooked up where there's one tool spanning across languages or multiple tools spanning across languages that could in some way be a common reference point. I don't know if that's a good idea, but something to discuss maybe. Individual tools have different strengths and weaknesses, and there's certainly going to be controversy if you sort of, for example, say, oh, Enzyme is 100 times faster than adult C in this use case, but adult C is maybe more stable or something like that, right? And so you make some people upset because they've done this thing that is really robust and easy to use, but you can maybe do something clever to get better than this. So these various trade-offs that we have, you have to think about runtime of the generated code, compile time. We have competing objectives: robustness, user-friendliness, speed, memory. So it's not perhaps as easy as an optimization benchmark suite, for example. We can say, this tool solved 90% of the benchmarks correctly and didn't solve the others or something like that. There's not always a clear yes or no answer. So I guess it would be, some work is needed to define how do we want to define the benchmark score, or maybe there's multiple benchmark scores, right? Maybe there's like a memory footprint score and a speed score or something like that, but we'd have to somehow think about that. And then, of course, any benchmark suite has to require some kind of community buy-in so that it's actually used. People, use it as a benchmark in papers, maybe contribute new use cases, and so we'd have to think about how to get to a point where we can do that, right? And so with those sort of motivational things, I want to unfold all of this. So questions that I want to discuss, sort of motivated by this, right? And I'm going to sort of drive this going more or less one by one, but people can have thoughts to any question at any time, really. One big question: do we think that a community benchmark suite is actually a good idea? And if everyone just says no now, then we can all go for beer. But otherwise we can dive into. That's tempting. I know. So if we come up with a yes, then we really want it. And apart from maybe everyone thinks, oh yeah, it would be nice to have a benchmark suite, but would you actually use it? Would you actually contribute to it? Right? That's a much harder question to ask. And then what should it be about? Should it be about performance? Should it be, we heard about all these correctness pitfalls, so should it be maybe functions that are tricky to get a correct derivative from? Should that be part of a benchmark suite, or should it really be about, easily differentiable things, and we just care about performance? Should user-friendliness be a part of that, or the quality of the API, and if so, how would we measure this? What we do about the different languages and the language barriers? How do we keep it alive and relevant? So one idea would be, for example, if we could have like a regular workshop at some conference. There's a number of conferences that take workshop proposals, and the correctness people have that, for example, workshops co-located with SC that just are about, how well does your tool do in data rinse bench, for example. And that's a track that people can submit stuff to and get a publication out of it if they actually contribute in a test case. So that could be a motivation. If we want this, what would be suggestions for test cases? Maybe we have thoughts on how it should be organized, and maybe people have completely other thoughts. So that's sort of the rundown of what I think are interesting questions to discuss. And with that, I want to sort of open it up a little bit more to the room, right? Thoughts on should we have such a thing?
I think first question is unquestionably yes, we should have a thing. I think a couple of just like high-level thoughts on that before I get into some like specific details that I think are particularly relevant here. So I've seen AD Bench used in a bunch of papers because it is relatively easy and because it is there. Like, in the first Enzyme paper, as an example, like we needed a benchmark suite. We wanted to make sure to demonstrate, right, we're not handpicking benchmarks. And the closest thing we found to a standard that was used in the community was AD Bench. ironically, this is like as an example, our GPU paper from SC21. When others started doing things in parallel to our GPU, like I know several others who have since re-implemented the like random Lulesh and other GOE proxy apps that we used inside of that benchmark into like I think Fusar, like a functional language, and a couple of other things. So like the fact that people like want to do this clearly shows that there's a need for it. I think the issue though is sort of like was alluded earlier. There's a lot of issues with making it easy for people to use and develop such a thing. I think first of all, right, like if you have something as a benchmark which is too specialized, then it's going to be difficult for people to use it because they're not going to be able to use it within their application, right? Like, which is where AD Bench has been successful in the past because they have like implementations in a bunch of languages, functional, not functional, whatever else, which of course means that there's a lot of caveats with that, right? Like, if you have a functional form that allocates memory for everything, there's going to be an expectation that there's performance differences. So it also doesn't quite work as the apples to apples, but the fact that there is something that is sort of like multivariant means that it's a little easier for adoption. I think, in my mind, the biggest issue in creating a benchmark suite is ironically not the fact that we need to ideally make it easy for multiple languages, multiple different ways of doing things, like like the mutable, the functional, the like using typing direction, using all these other sort of pieces or whatever else, or easy, small, big, whatever. I think the biggest issue is making it easy for not like an AD tool to use it, but for like a potential person who wants to write a paper or to benchmark something, to be able to use such a benchmark suite, ideally contribute for it, and equally so for whoever is an application person who just wants to be able to get their thing to work, ideally contribute that there as like a goal for perhaps AD tools to be able to do. There's recently, in sort of like the large language model sort of community, been a great effort of like, I forget exactly who, but like made a leaderboard of like, all the top language models, and you vote on sort of which is best. And the fact is, like things like that, and there's a bunch of examples on like, either HPC or et cetera, where, people can contribute problems that they think are hard. And then as a consequence, people who are developing tools want naturally to say that they've solved hard problems, so they do it. So there's actually a dual motivation or there's an incentive structure for both people who have hard applications to contribute to something, as well as for users or developers of the tools to want to show that they have it. The issue is we need to make it easy for those people to contribute, right? Because if you have just like a file set of things, and this is ironically something that we've even seen in the context of like fixing bugs for people, right? If I need to download some giant data set and set up some very specific things, the fact that it is hard to set that up means that like I'm probably not going to do so, because like even if the documentation is full complete in a doc or whatever else, the number of steps that it takes to go through just adds so much difficulty when I could find another random thing. So I think making it easy to use, and ideally, in a situation where, like maybe there's some continuous integration running on the website, like constantly rerunning things, or like you could very easily see what's happening. I was actually talking with a postdoc at Berkeley who's on artifact review committee for, I forget which conference, her name is Grace, and like she was telling me about this great idea in which, spent half the time doing artifact reviews, which is not the same thing as benchmark, but obviously involves benchmark, reproducibility. And like half the time, like the things didn't even work, and the other half of the time, like there was CI or something on their thing that like could have been just a literal automated check. Yes, that is already there, or the exact opposite. This would have trivially failed. So to the extent that we can incorporate something where, in both directions, like a submitter can submit something, just quickly runs against everything, and like a user can quickly like download and do this stuff, I think would be the most valuable part of this process, because it's the community building, in my mind, which is most critical to creating a benchmark suite, more so than any of the specific benchmarks.
In what you mentioned, there are two sets of users. There are users of the benchmark who write AD tools, and there are users of AD tools who would want to contribute in benchmarks. And like, we need to balance between these two. So for a user who just wants to contribute a use case, it's like, can I just dump my program on you and you make it faster? It's the best usability possible.
Yeah.
And it's reverse for AD tool writers, so we need to find a sweet spot that would suit both.
Yeah. And ideally, we have some sort of like at least partial automation, where like, we don't make it that it's entirely across the two feet. Should I get closer to that? Yeah. I think the ideal situation in my mind is that like, we don't push it, again, either one on the other, but even, collectively, if we sum up the two efforts from either the tool maker or the application developer, that should not be the sum of like, getting anything working end to end. We should be able to, in whatever benchmark suite, have the infrastructure to, reduce the total work. So either end doesn't end up with, 50% or more of it, like 35 or 40, 50% of it is already sort of automated by virtue of the infrastructure for the suite.
So do I hear that there should be some sort of agreed upon standards as to, a benchmark should pass these tests, or it should provide this kind of interface for an AD tool?
Yeah, which also like makes it easy to do some of these automated tests. Like something, as an example, we have in our integration test suites, which is basically a copy of an API from Google Bench or whatever else. It's like, we have this number approximately equals this other number. And if it is, great, the number is correct. Or similarly, you can imagine things for timing infrastructure, right? Like this is something that obviously all benchmarks need, but it's not something that we should have each benchmark separately write for themselves. Like we should be able to have like a timing library. Each of them imported, they say, here's the function I want you to benchmark. It calls it X number of times, it checks that the output is as expected, and then it says, here's my number with variation or whatever else.
So I could keep on that discussion for a while, but maybe also to hear from people who are a little more on the AD user side, what would you find useful about a benchmark suite, or what would motivate you to maybe contribute a miniature version of your application to such a benchmark suite? Right? Because I mean, we can't. It can't evolve into, hey, here's this climate code. Please, please differentiate this with all the tools. Right? So, how would AD users maybe want to interact with such a suite, if at all?
But if the climate code isn't part of the suite, then you're missing some of the axes you said were important.
Oh, I mean, for sure, right? I mean, it's sort of a question of who does the work, right? I mean, if we have this, what Alex said, right? If we make it perfectly user-friendly for people who contribute test cases, anyone could just send us their program, and it would be on us to differentiate it, which I don't think is going to happen. So where can we maybe meet realistically?
Where is this benchmark like it should be some kind of hardware, because contact users with numbers that they don't have to look at the discrepancy on, oh, this one will run on this newest machine, and this one will run on some other machine. That's why they're different. So you have implementation and hardware.
Okay, I mean that's another question, right? So the hardware would have to be the hardware would have to be part of it if it was really about timing numbers. Right? If we say, okay, this benchmark takes 7 seconds to cover up, then we need that to be reproducible. I don't, I mean, maybe people have ideas, but I don't think we have the resources, and especially not the sort of long-term stable resources that we could run this benchmark today, get 7 seconds of an enzyme, and then 20 years later you can come back and still get the same number because nothing will be around anymore, right? And of course, and like all the other benchmarks that I mentioned earlier, they don't have this problem because they don't have the right number. So maybe the benchmark should be more about what fraction of programs can you get correct derivatives for at all. Or maybe the memory footprint could be slightly more reproducible on different hardware. Or maybe we find a way to actually make it about timing. I don't know.
I mean, I think one thing which is still true of like the MS style examples is, for one thing, the benchmarks that do last across longer periods of time, one, are agnostic to hardware, which one makes it difficult to do things like GPU benchmark. Obviously, you need that hardware because you can't run it on a non-GPU to do a GPU benchmark. But two, right, like, if you have a benchmark suite, it's still valuable, even if you don't have a global leaderboard at some point in time that's tracked, because any individual user who wants to write paper or pearls on it, as long as they can run all the benchmarks on a fixed machine, they can still make the comparison that they want to make, saying like, hey, it gets this number correct, this time, or whatever else. Of course, it's subject to whatever machine that they ran on, but the fact is that it can all compile and test together means that you can still make a claim, even if
in your paper you pick one computer, and my paper you pick another computer. I can equally, run all the numbers on my machine, see it's valid, or if I really care about exactly your numbers, go find a machine nearly identical to it. I think there's a separate question of, once there is a benchmark suite, you can imagine, having some leaderboard style thing where we just continuously run all the pieces and people can look at it. In the LLVM community, there's actually a LLVM compiler tracker, and we have a variant of this that really hasn't seen any love, partially because too many things need to give love to. Similarly for like Enzyme benchmark sort of compiler runtime tracker, that just there's some machine donated by some company or academic institution that runs all the compiler jobs to check that LLVM builds, and just like it checks that LLVM builds, we'll run all the tests and just keep that in a JSON file that continuously updates. Obviously, as time goes on, eventually hardware deprecates, so you're going to need to every so often update it. But even having like a continuous stream of this for whatever hardware box is chosen for like the 5 years or whatever, and the next hardware box, even that I think would probably suffice for the sake of like the same hardware consistency. But I think irrespectively, it would still be useful if you don't have a set running in the background platform, so long as someone can run it without issue.
I mean, coming back to maybe people who might contribute cases, right? So as an example, CFD, for example, you could have a test case where an airfoil flow comes straight from the front, the thing is symmetric, we know it should have 0 lift because everything is symmetric, and so you have an analytical result, you can run CFD solvers against it, you can see how they converge, and of course it would be nice to have something like it for various applications, right? I would say this is a miniature version of, say, a climate code, and if you manage to make your AD tool fast on this thing, it will likely also be fast in practice. And by the way, we know the correct derivative result for this thing. That becomes then sort of part of the benchmark that you perform only matters as long as you get the tolerance of the number that we know to be correct, right? I mean, that's so what I would think would be a very nice benchmark to have. Obviously, this would require users who are interested in AD, but not AD developers to have the motivation to develop such a thing.
I think the correct is really crucial. There was actually a series of tests in Julia where we did tests or something. It's like the order of 100 functions and the correct derivative. And I kind of just put it into the enzyme tests, and doing so maybe like 5 or 6 times or something. So just that process of putting it in was helpful in itself. So for me as an AD user, I'm much more interested in different cases to prove correctness and speed, because I feel you can get a very quick idea of speed by just trying out a program or listening to what people have to say about it. But to really understand correctness, you just want to see can it run these difficult test cases. If it can run everything perfectly, you have a lot of faith in it. And there's thinking particularly about the options in Julia. All of the options would fail on something, because in this benchmark there would be a mutated case that Zygote would fail on, and there would be some enzyme fails on, there would be something the forward diff fails on, and so you would just be able to see with the ticks and crosses where each one's applicable.
Right.
So you mentioned QDist as a benchmark suite that the optimization community uses, and all of those have functions, gradients, hessians. What is the obstacle to us using QDist or some other optimization suite as at least one of our correctness tests?
I don't want to say that on the record, but have you seen the code? But yeah, sure.
But I mean, to some extent, we face that with any suite that we develop or work with, right?
Yes.
If we want it to be available in many different languages, we somehow have to surmount being able to create different versions in different languages.
That's true. There was someone just behind you. Yeah.
So I'm a little bit confused. You guys mentioned I have this climate code, for example, and it's written in Julia, and I'm going to run it through make a benchmark. What I don't understand is how do you exactly bridge the gap between someone writing a solver in Python and the same thing in Julia? So yes, you can have timing, so you can have Julia code, right? And you can say, this is my benchmark, and I have like, you know, Zygot and like, you know, enzyme blah, like, you know, the whatever, like, you know, AD tool, like, that I run it on, and then, you know, like, I benchmark correctness, I benchmark timing, you know, other things. But, you know, what I don't like, again, because I've never used AD tools before, so I just was hoping to kind of get a clarification on this. How do you compare, like, you know, the equivalent Python code, for example, with the equivalent Julia code? And judging by your smile, I don't think you have a good answer, but, you know, at least. And, you know, what I was thinking is that, you know, like, there is correctness, and there's, like, you know, correctness tools, which is, you know, we want to see what we get the correct result. There's also, like, what part of the AD system is lagging behind. So, you know, AD systems, like, you know, I'm sure you guys know, have different components, right? You know, you have to, like, either your DSL based, you know, like PyTorch, TensorFlow, and, you know, basically every introduction of Billy's papers, like, you know, basically this is a DSL based. So, but DSL based work on language, are language specific. Whereas, like, Enzyme is trying to be somewhat language agnostic. As long as you lower this to LLVMIR to MLIR, we can take care of it from there. So, like, but what part of it is, but, you know, there is no common ground with, because Enzyme works different, because Enzyme is compiler based, for example, whereas, I don't know, like PyTorch, I mean, like, again, you know, it can be DSL based, as in, like, give a given function X, I have its adjunct. So, to me, it doesn't put these, like, different tools on a different footing, because it's like, they have different processes. Whereas, like, you know, we're, like, when we say AD tools, like, we're kind of assuming that, oh, we're all, like, kind of doing the same thing, whereas they kind of have, like, a different starting and finishing point.
Yeah, I think that there's sort of like two components of that, which ironically can be solved separately. I think the first of which is sort of, you know, like the rewrite the benchmark style problem, right? Because as soon as you have a benchmark in one language, one framework, especially in the DSL context, right? Like, you're going to need a different version of it. Like, I want to use PyTorch. None of the existing even Python code will work, because I need to use the PyTorch variant of these APIs. The second of which is sort of, you know, even then you can imagine doing like a partial comparison. There's going to be like a lot of differences. Like, you know, I'll talk about, like, you know, say JAX and say like Julia, because I know a bunch of like internals now from staring at the insides of them. In the context of Julia, right, you have to, and ironically still even JAX, you spend a lot of compile time overhead on your first call, where it JITs everything. In fact, doesn't just JIT, you know, like your function, it might JIT all of the, you know, package or whatever else. And, you know, perhaps this is something we should still time, but like in one bucket to be compared with follow-ups with the, you know, Julia-specific way of properly timing it. In Jack's case, you know, it also has JIT overhead, but like the other really interesting and slightly weird for the sake of making benchmarks proper thing that it does is the Jack's returned arrays are lazy, which means as long as you don't print them, add them, or use them in a different computation, it will never actually materialize them. So getting proper timing requires doing a whatever dot block until ready, which forces the lazy evaluated return feature to now be guaranteed to be completion. So doing proper timing for this requires, you know, similar levels of extra fancy stuff on top of it. I think, you know, in reference to the second one, like, you know, each language, and, you know, in the context of like the JAX block until ready lazy sort of thing, like each framework may have different sort of sets of caveats that can be generalized. Like in the language context, right? Like, you know, there's plenty of good Python timing tools. We can like set up similarly, like here, if you have a Python thing subject to other things that you might want to add, like the lazy future style stuff, you know, here's a way to time your function. In the Julia case, right, there's wonderful, you know, benchmarking tools like btimer or benchmark tools that will first run the JIT compilation overhead and then actually for the benchmark on the inside run it multiple times. So I think we can at least abstract that away, and that's not even an AD specific question. It's more of like a multi-language, multi-framework, like get all these things to be cross-compared.
I mean, it's still a question to me. Like,
oh yeah.
It's like, because, you know, again, scientist A comes in with their code, and, you know, it's, you know, in Python, in Julia, in R, or whatever, and, you know, they want to contribute this as like a benchmark. So like, it's still not clear to me like what the process will be to make it like fair
Yeah.
to other AD tools.
So, I mean, about the fairness, I think there's a question of marketing, right? That I think a benchmark suite like this should not be, and should definitely not be perceived as sort of a competition between, JAX is number one and Enzyme is number two or whatnot, right? Because as you say, it's sort of every tool has different capabilities and there's so many trade-offs. Right? I could imagine the output to be a much larger table where we see, all the Python-based tools happen to do great on linear algebra stuff, but I can't even tackle these other use cases at all. And then, something like Adult C or Enzyme does great on this unstructured stuff, but lags behind other tools when they can really shine. So I don't think it should be sort of a ranking of, putting all the tools in order. It might be more of for someone coming in and they know their application is in Julia and it uses unstructured stuff and it uses nonlinear solvers and this and that. And look, in the table there are 3 tools that can deal with this kind of problem, right? And then 5 others that can't, or something like that, right? Maybe that's a motivation, or maybe.
I mean, it can be anything, but I think it's good to clarify what we want to do with this.
Oh yeah.
Because I guess one of the things. So when you're starting a project from scratch, the first thing you want to kind of contemplate on is what language am I going to use? Because sometimes, you're starting from legacy code. It's written in Fortran. Even though, I haven't seen any new PhD students being trained on Fortran, but it's still there. We want to and it still performs well. So do we want to use that, or do we want to use Python? Everyone uses Python. It's easier to kind of communicate. Except this group, everyone loves Julia, but if we step out of this room, people are not still treating Julia as a viable option still, even after it's just come from a long way. It's come a long way. Or do you want to use C or C++? C or C++ is is de facto because you can't really argue with that except from a productivity level. So still it's if you're starting a project from ground up, you want to see what are the options. If I use this language, X language, why am I going to get better performance? So what does that mean? So what I think it's I understand what you're saying, and I think it's better to kind of clarify it.
Yeah, and I agree with what you say, right? In the end, it's a user choice, right?
Yeah.
And there shouldn't be a clear ranking, but I think potentially the benchmark could tell you something the C++ tools are all 10 times faster on unstructured problems than the Python, or compared with Python, I don't know, 100x or something like that, and maybe with Julia you lose a factor of 1.5, but maybe you know that you're going to be more productive or something like that, and then in the end it's going to be up to the user. It has to be up to the user to decide, right? So that's why I don't think we can say, Julia is the best language for AD, right? Well, yeah, but maybe your code is in Fortran and you want to use it, right?
No, kind of that makes it harder for your average domain scientist to kind of make it available across languages, which is I think what you guys are discussing. So
I think at one level this is a question of what is the priority, or at least to begin with, right? There's a lot of reasons a benchmark suite could be useful, right? From my perspective, the immediate reason the benchmark suite is useful is, like you sort of say, eventually we come up with a great technique for, say, doing linear algebra or doing whatever else, or we built Enzyme at first and we want to do a fair comparison, and, you need some benchmarks for that. You want to be reasonable at it. So, from my perspective, I think a benchmark suite is useful to be able to, compare the things that we've built in a fair way without hand-picked sort of things. From the applications, people point of view, you want to be able to sort of see what the level of support and trade-offs are for the various things. So the point of a benchmark suite from there is to make an informed decision, and eventually you have the person who's trying to pick what projects that they want to do. And similarly, they look at a benchmark suite as a way of learning about the ecosystem, so to speak, to be able to make their informed decisions. I think to the extent that we can make these all productively intertwined is useful, but also at some point you're going to have to make a decision about, like, you know, at least to begin with, what is the first thing that we should aim to tackle? Because if you try to tackle all problems at once, it's going to be hard to do any of them successfully. Like, you want to structure it in a way that you can get there, but like, if you aren't able to develop something that at least has a core initial user base that you can grow out and like go towards the other things. So I think, I guess maybe this goes back to you, Jan, of like, what of the different priorities do you think should be a first target?
I don't know if I want to answer this question, right? It's maybe something to get input from, because I don't see sort of myself single-handedly developing a benchmark suite, right? And I think, you know, whatever most people think should be a priority would help us get some critical mass and get something off the ground, right? So maybe playing the question back to the room, like what would make people want to contribute to such a thing and use such a thing, right? Would you see this more as, you know, do you want across the languages, do you want to be able to compare your AD developments with other things, or, you know, do you want to be able to see the landscape, and then maybe we should focus on that? Please, thoughts from the room around this.
Usually language is like something that I can't control. I will use the language that my lab is using. I can try convince them, but chances are that, oh, we have code that is in Fortran, so you have to use Fortran. So I think beginning it would be easier to just, oh, these are the problems that we want to solve. For example, there are 5 equations that you need to solve, which are pretty tricky to get correctly by your AD solvers, and implement them in C++, and this is like, it's just a pass-fail benchmark whether these equations are correct or not, your results are correct or not for these 5 questions. Then, oh, these are some questions that users have submitted or we have gathered, we think they are interested in cases of performance, that if in the given language, this is the implementation and this is the result that we got. And then I can say, okay, I want to work in this language. Let me see how many different frameworks are there that are getting this particular problem correctly and what are their performance. Because chances are there can be some problem which are tricky to get correct, but I don't care about them because I know in my system they will never occur, so I need to go for higher performance version of that particular one. So in that case, I think easier would be just target, let's say, few languages that people who are creating this benchmark are comfortable with, and then later on people can add more and more languages when they translate these problems into their own domain because they want to compare one-to-one, but what is the
I would probably even echo that, because a lot of the samples of benchmark suites, not even the AD ones that you sort of mentioned, like you talk about Polybench for the context of that, like that is a tiny C benchmark suite of tiny things that, you know, has been so successful as a tiny C benchmark suite used by people that people have since rewritten and various other things, like people have rewritten it to use GPUs, people have rewritten it in different languages, and so on. But like, it started as something that was, you know, targeted, and then because it was so targeted, all the people in that area were able to successfully use it. I think AD Bench sort of did this in part. I think AD Bench, you know, like the sort of like de facto vanilla implementation was inside of C or C++, and you know that got all of the C tools. Like, you know, you got Adapt, you got Tapanod. We used it from the C++ side of things, and like several others. They also, however, you know, like they looked at the AD landscape at the time, and they did a best effort, like re-implementation of the C in styles for other frameworks. Which I think, again, the fact that because all the other AD tools saw that and latched onto it, like led to it being successful for that. But also, as you sort of mentioned, it stopped being used at one point, partially because, you know, it's, you know, not been growing of benchmarks and whatever else, and there's only so much you can get out of that set at the moment. So I think, yeah, I think if we can start with a very, you know, core set of things in one language, or perhaps like a couple languages where it's like, you know, it's going to still be controversial whether or not 2 implementations in different languages, let alone different frameworks in the same language, are equivalent, especially in the DSL case. But to the extent that you can make the argument that these are, you know, like standardized, that people think are, you know, relatively vanilla, then people can build off of that because everyone else's expectation that it is standardized and comparable is there, and people can, you know, continue to do that.
So does that sound like, you know, building onto AD Bench with sort of similarly sized, easily translatable problems would be the right approach?
I mean, it seems to me that in order to be relevant, the problem should be somewhat complex, right? Because 2 easy benchmarks
I mean, one can very quickly write some toy problems or simplified problems that are nice and that one can even take shortcuts, like if it comes to memory requirements and so on. But then the minute you want to scale this up to the real application system that you're actually interested in, they are no longer relevant. I mean, maybe that echoes a bit what you said. But then that, of course, if you go into more complex applications that are interesting and relevant, that also means that their implementation or a new implementation with a new tool takes time and person power, right? So that's not sort of an easy thing to do. So these are some caveats. Now, of course, now very, very subjectively in the ocean case, we are actually in a position where we can do some things. We have a 2.5 decades of experience. So we have used AD with an ocean model for 2.5 decades. We now have at least three AD tools that are quite independent. We have the commercial tool TAF. We have had OpenAD, and now we have an implementation of that ocean model in Tapenade, and we can configure that model both in realistic and configuration, but we can also configure it with idealized test cases that can mimic sort of something that is much more like a shallow water equation. We can really downscale it to something like a simple application where we have this. And the prospect now is actually in this specific community, we can actually try this Fortran code on Enzyme also, right? So for the first time we actually have, so we can have TAF Tapenade and an Enzyme implementation, which would probably take time. And then the next thing we're basically on the verge of doing, we actually have two Julia models that were, so one, the Oceananigans, the other one is the AMPAS sort of prototype of a DOE type ocean model in Julia, also working on enzymes. So we actually, in this very specific case, we're beginning to have really both a set of AD tools and at least two very different codes where we could begin to think about idealized configurations that try to, they will not be the same solvers because they will not be the same, using the same numerical algorithms, not the same advection schemes. And so the issue of one-to-one comparison of the details becomes difficult, but at the same time it becomes quite attractive actually for this specific. It's a very, very narrow-minded, but I'm just saying because I'm an application person, where there is actually a possibility to think about comparison across the AD tools, but also comparison across the numerical solvers.
So that would be a very nice test case to have in the suite. I mean, sort of reading between the lines a bit, there's of course at least two different kinds of challenges that you're facing, right? One is if you're dealing with a legacy code, you have potentially all these language features that are very tricky. And that could be part of the benchmark suite, although I think that's impossible to make language agnostic, right? So if, if type stability in Julia is a thing you struggle with, that's Julia specific. Nothing you can do about that. But I guess the other problem that you might have had is maybe more related to actually two kinds of problems. Can the AD tool deal with custom linear solver rules or custom optimizer rules, or will it allow me to do checkpointing and not run out of memory for this kind of problem, right? So these are sort of three very different objectives, I guess. And I'm not, maybe what are people's thoughts? What would be sort of a top priority for them when considering a benchmark suite? Should it be about completeness of language features, or should it be about performance, or should it be about getting correct derivatives for tricky functions such as ODE solvers, nonlinear, linear solvers, all these kinds of things? Should we have a zoo of complicated maths? Should we have a zoo of complicated language? Or should it be more focused on performance or memory or something like that? Does anyone have thoughts?
Why not all of them? Why not all of them?
coming back to we probably should have some kind of focus at the beginning, but you know, like if you had to pick one, you know, which one would it be?
So I have a lot of thoughts on this, mostly because we run a similar benchmark for materials and their models. Okay. So what we have is basically like 3 kinds of benchmarks. One is your correctness benchmark, which is just pass and fail, and you will get like, there are some constraints of physics. Suppose if I give an inverted symmetry, whether my material is still giving same energy and forces or not. If not, then it's just a fail, and that's all. It's not like whether we are saying this model is good or bad. It's just that does this model pass this test or not? And then it's up to user to pick whatever they want, because like I said, it's usually up to them whether they want to have this trade-off or not, because even if suppose there are certain models which might fail certain cases, I don't care about those cases because my research will not deal with those specific cases. Right. Second one are your performance-based tests, where we will give same size of problem to every different potential or every different model and see which model comes out on top, because like I said, someone might want performance and they don't care about correctness, etc. Or they don't care about correctness to that degree. Like I'm fine with 10 to the power minus 6 tolerance as long as it's fastest. And then the third one are application specific. So when we first started this benchmark, the first generation of benchmarks were really simple. They were just give a simple set of atoms. Can you get energy and forces? And we have some reference, and then we can see how far away it is. Then after a few years, people were like, oh no, this is good enough, but we actually want to do something more out of it. So then people started contributing more sophisticated benchmarks, which were like compare lattice parameters, whether they are there or not. And now we are in 3rd generation of benchmarks that are currently going online, most likely next week or so, where you are running entire simulations to see whether you get results what those simulations should predict for some standard DFT, etc. or not. So I think complexity-wise, eventually you wouldn't need everything, but I think starting you can just pick like 1 representative problems of each of them, and so that people will know that, oh, this is a kind of test where I can just check for correctness of some particular functions. These are just pass and fail. These are the kind of tests where there's some more complicated code, some linear algebra code, or some simple problems, and I can see, oh, this kind of your enzyme performs better than this particular framework in this language. This is what I care about, so I can at least start with this one. And third one can be more specific or more domain specific, like someone is running some environment or some atmospheric simulation code, and there's a huge following in that community that uses these kind of one. So someone contributed, oh, this particular community might follow this benchmark. Fine, then we can run that one as well. But eventually, I think I think starting point should be like 1 from each slab, so that you already have users that this works. It need not to be completely extensive, but at least that framework would already be there if people want to contribute more to it.
Okay. I think for me, it would for sure be just user friendliness. Like it could be a benchmark that is worse at everything. If it just takes me less time to actually like use it, I'm gonna use it first, and then afterwards I might add all the benchmarks that are better for the other things.
Interesting. That's probably the one that's hardest to measure.
Yeah.
but okay.
But I'd say that if there's an example for like my particular language and my particular thing that I'm doing on that particular benchmark, right, I'm gonna go with that one, even if it's worse.
So for you, the benchmark suite would be almost like a zoo of examples, I guess, of how to use different tools in different languages for different kind of problems. More, so that you don't really care that much about the results. You would rather look at how are things differentiated.
Yeah, basically, like if it was easier to use that benchmark suite, I would like start with it, and then eventually like I could go to the other ones once I find the limitations. But initially, I would go for user friendliness.
See people looking at the time.
I have a comment from Jed, who's on the live stream.
Okay.
Specifically, who says mixed language is particularly interesting. He's hacked Rust with C with manual LLVM passes, but would love to have better tooling. Being able to differentiate without allocating is particularly relevant in the context of GP work, and a lot of tools don't have that capability, at least when the compute graph involves inner iterations. Pausing a second regarding timing. We did start roughly 15 minutes late.
So we have 10 minutes left.
Yeah.
Okay. Yeah, we can do a few more. Multi-language, that's of course, so I mean, maybe coming back to that then, does it need to be a multi-language test case? Or is it enough to have test cases for all the languages that you're interested in, and leave the plumbing up to the user? Because not trying to push against it. It's just if the benchmark suite should also contain combinations of languages, then we are just sort of growing the order of of complexity here.
Yeah, and not to be the Jed whisperer, because I don't yet have a response for that, because there's a lag on the stream, of course.
Give them a moment to reply.
But the one thing I'll add is I think he was more interested from my read on mixed language more so than multi-language, like the combination of this code and this code together across language, which is obviously a whole different can of worms too, because some AD tools may only work on one language, so it's actually a problem more so, I think, of composability between different things, or the interfaces, which goes back to the earlier discussion as well. As like, there's a lot of things you could try to include in a benchmark set. Some of which are easy because there's like graphs that you can make of like performance numbers or number of things successful. But the sort of like API design, right? Like how easy it is to use, which this could fall partially under, but also just like how easy the API to use is something else that is a qualitative thing. I don't know how it would be easy to incorporate, at least.
And I think that could be part of a good benchmark suite, right? Is to have some sort of common way of calling AD tools, or at least sort of a calling convention that is easy to do across tools and across languages, which could maybe motivate then interoperability as well.
Yeah. Also, I now have a response from Jed who says, yeah, it's mostly a pragmatism when working with legacy code.
Right, so legacy code that has multiple languages, then yeah, because right now you're pretty much stuck unless, I don't even know of an unless. Maybe with Enzyme?
We have done some cross-language differentiation just because, like all things go down to the LLVM level. Like it sounds like what Jed did, right, was, like use the Rust compiler to generate LLVM, use the C compiler to generate LLVM, like, combine them together with LLVM link or something. We've done some things that make this slightly easier in Julia, where if you call a C library function that's compiled with LTO on it, we will make the version of this forcible linking of it automatic, which there's definitely other ways that you can improve this and should make the interface for that better, but I'm not sure what the right way to do this interface design is, just because multi-language is such a difficult feature for an AD tool to provide.
And it might seem, if we are proposing a benchmark suite that lies heavily on multi-language, and then conveniently Enzyme is the only tool that can do it.
Yeah, I'm not sure that's the fairest way of doing things.
There's a flavor to it for sure.
Yeah.
Because yeah, I mean, like I said, I think to get buy-in from a lot of AD tool developers, right? It should really not be. It shouldn't look like a competition between tools, particularly not an unfair one.
Yeah.
Which I think is definitely something to keep in mind. Yeah.
So, sorry to barge in, but it sounds like to me as if we're talking about two different things here. There's documentation. Can you hear me?
Yeah, I can hear.
So one thing we're talking about here is documentation, right? And that is, let's define that as a model zoo or some sections of code which someone can look at and understand this is how it's done. The other question, and that must be readable, that must be explained, that must be easily compilable, all of this stuff. The other question is benchmarks, which you can take documentation and make them benchmarks, but benchmarks then would be specifically correctness, speed, and things like this. So is there value in drawing that line and saying, look, we're going to do some documentation, and maybe the correctness test might be a documentation in some sense, because they'll encompass a wide range of the capability that you want? Or are you saying, we're not going to do documentation at all, this is purely focused on, here's my problem, here's what happens?
So can you clarify what is on that line? So one would be nicely documented benchmark cases, with like this is what it computes, this is what the derivatives should be, and on the other side you have.
On the other side is throwing multiple ADs into an ocean model and seeing what works, or this like crazy scaling, sparse matrix testing.
And I mean, I'm not sure if there's such a clear distinction, right? I mean, either way you need some kind of yes or no answer about is the derivative correct or not.
Right. But I guess the question is also, because I think, sorry, I didn't catch your name, but as you were sort of saying, what you would be most interested in is a sort of almost a quick start, right? As in, I see this code for all these libraries and I see what it can do. And I feel like that would fall more into the realm of documentation because it requires more effort for you to say, this is exactly what this is doing, this is where it fails. If you put a sparse matrix of n more than 2000, sorry, bye-bye, right? As opposed to a performance case where you say, broad strokes, here's an ocean model, it uses this solver, these are the general sizes of matrices and so on. And this is the result.
Okay, yeah, that's actually very interesting, right? Because I think it motivates a discussion about how would people use this benchmark suite, right? Because yes, it's not a runoff between which tool is better, but maybe you're coming in and say, oh, my code is unstructured and uses mutability. So I only want to look at test cases that use that feature, and that would rely on a documentation that includes whether or not it has that feature, right? And so, I guess that's something worth discussion. What kinds of categories would people think are useful to include, right? If you're trying to interact with a benchmark suite like this, probably you want to care about, is it unstructured or does it use mostly linear algebra? But maybe you have something else in mind.
Kind of touching on that point is whether the benchmarks are actually defined by code or defined by specification. So as in, are we saying, okay, here's a block of code which is provided by the suite that you have to run AD on, or are we saying, here's a kind of specification of a function with inputs, the algorithm, the prime and output and derivatives, and you have to match that. And I think that's two different things. And if you want a multi-language benchmark, you're probably leaning more towards the specification side. Otherwise, you have to provide implementations in every language, and it also has to be compatible with the coding style of those things. I'm just thinking in Julia, the difference between Zygot and Enzyme. They use a completely different programming style, and so if your benchmark suite provides a Julia code, then it's going to be biased towards one or the other naturally. So you might want to provide more of a specification of basically a pseudocode.
No, I think the one caveat with that is, and this is sort of why at some level you need both of these. You need like a high level spec, but you also need definitive implementations inside of there. It's like in the context of Julia specifically, right? You could have two programs implementing the same spec that are radically different, both in performance, even ignorant of AD, because like it does a ton of extra allocations or is type unstable, which could just as easily for the performance side of thing also make a difference for whether or not an AD tool can go through that specific function or whatever else. So like there's whatever you're going to do, you need to be, I think, clear on what is being tested. And I think providing both of these is a way to...
So actually, the Julia benchmarks themselves have always been historically criticized by other languages for this exact reason, because they implement algorithms in a kind of non-efficient way to deliberately show that Julia can compile that type of algorithm, and other languages come in and say that's a stupid way to implement that function, and then the counter argument is, well, that's not really the point. So yeah, you do end up in these kind of arguments. But if you just provide a single block of code that you're supposed to use AD on, it's very hard to make that tool agnostic because you might need to change the coding style for different AD libraries.
Yeah, but I think like the gist is just as how the overall algorithm description is valuable for the sake of you can tune it to each code, what is the code that you wrote also equally matters. Like I could take, again, we can go past Julia and just go to a matrix factor multiplication side of C++. Like, am I writing this with proper non-aliased pointers that causes it to vectorize with SIMD and whatever else and get orders of magnitude difference from that implementation, and equally to the performance gist, like a AD12, right? Might not understand weird vector intrinsics that I've done, and I think in my mind, like a good benchmark suite has both of these things. It has like, here's a class of problem, and here's the implementations inside of it. And we can look at like the implementations inside of it and see how the things sort of match up in both performance and like whether or not it's handleable there. And we can look at the differences between these things to understand better. And sometimes you're giving power to the person reading the results of the benchmark suite, but also like still sufficient information that someone who, like in the standard Julia sort of arguments, like says like, oh, this is a really inefficient way of looking at things. You can say no, but here's the other efficient way of doing a thing. So you can still, for whatever type of comparison you're trying to make an apples to apples comparison. It just happens to be that having more information here lets you make different types of comparisons. Be it like I could do this with mutability, or I can do this with performance. And if you want to talk about expressivity versus perf, you get a different result.
It seems like we are now running out of our extra time as well. So maybe something to discuss during dinner, if there is a dinner. I'm sure people have some kind of dinner. I'll give it to you in a second. I guess, community building, what would make you motivated to stay in touch with an effort like this and potentially contribute? I'd certainly be happy to hear thoughts over dinner or later on, and hopefully we can keep the discussion alive and maybe create something tangible.
Yeah, before we cut off the stream, I think adding on to that, in case it's useful for folks, I can put around, including we can set something up on the YouTube for folks who want to like add their email to a discussion list or like ongoing discussions on these types of things where write your name and like we can make sure that future discussions on that, maybe it ends up in a white paper, maybe it ends up in a benchmark suite, but if there's something you want to be involved in, we can make sure you get to continue in contact.
Yep. Cool. All right. Sounds good to me. Do you want to say something about whether there's dinner or not?
For people on live stream, there is clearly